Welcome to this web lecture in which we look at the aspect of memory as part of the cognition part. So how does our memory actually work? This involves two different types of processes. One we call encoding, that happens when we're trying to remember something, to put something in memory so we can recall it. And the second process is to retrieve it back from memory, which we call recalling. Our memory, both input and the output, consists of filtering and processing. We cannot store everything we see in memory. We filter out events that we concentrate on, and we never even store other things in our memory, so we definitely cannot recall them because they were never processed to remember them. The context is also very important. There are things we can only remember when we are in the right context to do so. Generally, we are better at recognizing something than to recall it from memory. And that's what gave rise to the graphical user interfaces, which show us the options that are there. We only need to recognize the one we want. We don't have to recall names of commands from memory to then type them in. We are generally also better at recognizing images than words. So we have graphical icons and toolbars full of graphical icons, which are easier to use than buttons with names. Like the menus at the top of a screen, of course we can recognize them, but recognizing images is easier than recognizing all these names. We have processing going on in memory that starts by encoding. We see a lot of things, but we filter out some and we store them in memory. Our memories are often of a very strange kind. Some things we can easily recall visually, but in the case of text, for instance, we often recall what it sounds when the text is pronounced, rather than remembering the letters of the words or remembering the abstract concept. The more attention we actually pay to something, the more likely we are to remember it. As a result, for instance, repetition really helps to memorize something. If you're trying to learn a poem or a song by heart, right, you have to read it or sing it many, many times. Right? Musicians also are good at playing by heart when they repeat something very, very often. In this course on interfaces and interaction, we have assignments because by doing things, and you probably have to repeat them many times in the process of the development, you remember better what the principles are. Each time you again experience that someone has difficulty with something, you are reminded of the design principles that, oh yes, you violated them. The context is important because we cannot remember something in the wrong context. So it affects how we can retrieve information. And a simple example is when you meet people on a train. Someone can come up to you and say hi, and you cannot recall who this person is. But you may recognize the face. We say, yeah, I know this person, but where do I know him from? It may actually be one of your neighbors. It may be one of your classmates, but you see them in the wrong context. So please, when you see me in a supermarket, don't expect me to recognize you when I only know you from class. Let's do a quick activity. Try to recall your grandparents' birthday. this may be not all that easy, especially not if they are deceased. Right? I can remember my parents' birthday. I cannot remember my grandparents' birthday because this birthday we haven't used for decades. Now try to recall the cover of the last 2 DVDs that you bought or rented, or the last 2 YouTube movies you watched. You will see that this is easier, and this is easier because it is visual. And abstract concepts are not visual. So color of items, locations, marks on objects, they're all easy to remember. Numbers are difficult. Mostly when I remember phone numbers, for instance, I remember what it sounds like when you say them. I don't remember in terms of these digits. Recognition works better than recall, which means that command-based interfaces are harder to use. You have to remember what was the command, what was the name of a command that you want to execute. This works well if there is enough repetition. Unix users know that ls is the command for a directory listing, and mv for move. Right? These commands you use a lot, and so it's easy to recall what they are. And for lesser used commands, it helps if their name is really meaningful. One of the reasons why shutdown is called shutdown is, of course, that you don't want to type it by mistake. So it's a dangerous command. It cannot have a very short name. But it's also called shutdown because what it does is it shuts down the computer. It has a meaningful name. GUIs, and we see the Apple dock here, GUIs require you only to recognize icons. And if they're sufficiently distinct and the icon actually means something, well, this is much easier than recalling commands. Another thing that helps is that in browsers, in MP3 players, and other applications, they show you lists of historical information. So that, oh yeah, you want to hear a song again? Well, over here is a list of like the most recently used, the 20 songs, but perhaps it's among them. And you can recognize rather than recall what it was. Now in our short-term memory, there's a well-known theory by George Miller that our short-term memory can hold 7 plus or minus 2 items. So when someone gives you a phone number, depends a bit how long is the phone number. If someone gives you an internal phone number at the TUE, which is 4 digits, and you only need to use it like within a minute or half a minute when you have walked to the phone, it's a good chance that you still know it. If you have to remember it for a longer time, you have to concentrate on it and process it. Right? That's no longer the short-term memory. This principle, this fact of life that we can only remember 7 things for a very short period of time, has been used in interaction design in correct and in incorrect ways, as we will see. But we're first going to do a small experiment. I'm going to show you a phone number for a very brief moment. The question is, can you then recall it and write it down? So don't write it down while you see it, only write it down after it disappears. This is the number. Now write it down. Let's see. The number was, well, 06, 108, etc. Did you get it right? Did you remember that number for the few seconds it takes between you saw it and writing it down? This is actually difficult to some extent because, as you see, there are 10 digits. our memory can hold only 7 plus or minus 2 items. So in principle, this is too much. 10 is greater than 7 plus or minus 2. Yet some people will have managed to do this. We didn't say that you have to consider every digit as being a separate item. We didn't tell you what the items are that our memory can hold. So you can cheat by using patterns. And there's a well-known experiment where a Hungarian chess player was asked to notice a chess setup that was pasted on a van that drove by, and then place chess pieces in the right position. And even though that's way more than 7 chess pieces, she could do it. And that's because she recognized patterns, not individual pieces. They repeated the same experiment where the chess pieces were placed randomly on the chessboard, and sure enough, she couldn't do it. And because she also had no short-term memory that could hold like 16 items, and so having to remember individual chess pieces, no way this would work. Here is another phone number. We're going to repeat this experiment, and you'll see it works very differently. This is the number. Write it down. This is easy. Why is this easy? You recognized the pattern. You recognized it was 06 and then 1 through 8. This is easy. Right. Okay, so 7 is the magic number. What do designers do? They tell you, well, present only 7 options on a menu bar. And you should have only 7 icons in a toolbar. Have no more than 7 bullets in a list. If you have to list items in a text, for instance, no more than 7 bullets. No more than 7 items on a pull-down menu. No more than 7 tabs at the top of web pages. Well, all of this is wrong. Actually, it's not wrong. But it is wrong as an application of the 7 items in short-term memory. Because you don't have to remember the options in the menu bar. You don't have to remember the icons on a toolbar. You can see all of them. For all of these pieces of advice, you do not have to remember anything. Yet, it's good advice. It's good advice to not clutter the display with too many options. So while this is good advice, we have to consider, right, when are we actually making use of our short-term memory and when not. For instance, when designing an interface with tabs, we should avoid the case where the user has to remember something when moving from one tab to another tab. You can't see the 2 tabs at the same time. You should never need to remember something from one tab that then needs to be used to process something in the second tab. You have to ensure that you apply good design principles, and if you do so, especially consistency, right, that helps users to remember how an interface works. Right? So this is using their long-term memory. If you repeat what exists in other interfaces, your users will remember how to use your interface after a much shorter training period than if you do everything differently from everybody else. Even when you may think you have a great new idea, you are making life difficult for your users if you deviate from the standards, because you make it harder for them to remember it. Keep this in mind when designing your own projects. Thank you for participating.